Welcome to today's deep dive. We're demystifying how facial recognition AI actually works under the hood today,
Hmm.
and we're using this incredibly thorough guide by Debrada Prusif.
Yeah, he's an enterprise architect and applied AI leader, right?
Mm.
Really specializes in um, bridging that gap between high-level tech strategy and just practical execution.
Right, exactly. So our mission is to figure out exactly how these algorithms work. To start, I want you to put yourself in the shoes of like a bank's financial crime investigator. Imagine a passport photo just flagged on your screen as a potential match for a politically exposed person.
Oh man, the stakes are super high there.
Yeah. The names are similar, but you're just staring at this photo trying to figure out if it is actually the same person.
Right, because a false positive just delays an innocent customer. But, a false negative lets a high-risk person slip right through your whole screening process.
Okay, let's unpack this. Because people tend to think AI solves this by playing like a pixel by pixel game of spot the difference.
Yeah, I mean, that's a huge misconception.
Right. But Prusif's pipeline, which he builds using Python and this open source library called InsightFace, it doesn't work like that at all. It acts a lot more like a mathematical translator.
Exactly. But before it can even translate anything, it has to isolate the face, right?
Right.
It finds the bounding box, extracts landmarks, and it'll actually immediately flag the image if there are multiple faces in the frame.
And it also does this really strict quality assessment phase too, doesn't it?
Yeah, it does. The system is automatically scoring things like blur, brightness, face size, and just the overall detection confidence before it even moves forward.
Wait, so if this neural network is so advanced, why does a slightly blurry photo just completely derail it? I mean, humans can still recognize a blurry face pretty easily.
Well, what's fascinating here is that human brains automatically fill in those visual gaps, using context. But the AI is purely mathematical.
Ah, right. It doesn't have that context.
Exactly. It assesses its own input quality because the very next step, that translation phase, it relies on incredibly precise data points. So if a face is poorly lit or, like, too small, the math is just going to be fundamentally flawed from the start.
So if bad lighting breaks it, what is the AI actually looking at? Here's where it gets really interesting. Once it has that high quality isolated face, it creates what's called an embedding.
Right, and embedding.
Yeah, so think of it like turning a face into a highly specific GPS coordinate, but instead of just latitude and longitude, it has like hundreds of dimensions.
Hundreds of them. And those dimensions aren't things we intuitively recognize at all. The network isn't measuring the physical distance between the eyes or the width of a nose or anything like that.
Wait, so it's not looking at physical features?
No, it's actually capturing these abstract, high-level geometric patterns in the pixels.
Mm.
And those patterns remain consistent regardless of the person's expression or, slight changes in the angle of their head.
Oh, wow. So comparing two faces essentially just becomes a geometry problem?
Pretty much, yeah.
You aren't matching physical features. You're literally just measuring the walking distance between two high-dimensional GPS coordinates.
Exactly. And we measure that distance using something called cosine similarity. Since the embedding is a mathematical vector, cosine similarity looks at the angle between two vectors.
Okay, so how do we read that score?
Well, a score really close to 1.0 means the vectors are pointing in the exact same direction, which is an incredibly strong indicator of a match. A lower score just means they are mathematically far apart.
Right. But with a cosine similarity score of, say, 0.99, it really sounds like the math is basically just making the final decision for that bank investigator.
Actually, Prusif argues the exact opposite.
Really? How so?
Well, yes, the pipeline automatically ranks the candidates, visualizes the top matches next to the original, and generates this nice auditable CSV report. But it is strictly a decision support tool.
Oh,
You know,
okay.
it should never be the sole basis for a legal or security decision. Humans absolutely have to remain in the loop to, interpret the context that the maths simply cannot see.
So what does this all mean for the listener wanting to learn more? That philosophy of using AI to organize data while humans make the call seems really important.
It is, and you see that same decision support framework all over devibaradaprusif.com, especially with his next upcoming project on document intelligence.
Oh, the ROG system, right?
Yeah, exactly. He's applying that very similar mindset to a retrieval augmented generation, or RAG, system that reads complex passports and invoices. The AI does the heavy lifting, but the human keeps the oversight. It is definitely worth exploring the other blog posts on his site.
That's great. So we've journeyed from raw image detection and quality checks to extracting abstract mathematical embeddings, all leading to this human-guided similarity ranking.
It really does completely shift how you think about digital identity. Because if something as complex and, deeply unique as your face can be accurately reduced to just a simple mathematical vector.
What other deeply personal traits might soon be mapped as mere numbers? That is definitely something to chew on the next time an AI asks you to look into the camera to unlock your phone.